Hello, hello, hello. Good morning, Stats. I am on the road. I am going to do the teaching beforehand. So right now, welcome to Stats class for the day. And so we're going to go through the lesson, record it, and then post it. And kind of that's going to be how it goes. So questions can be asked during class. I will be live in class. But I think it'll be easier for you guys to watch the recording, probably easier for me as I go to do it on the recording, that type of stuff. My computer's limping along, so I think it's better if I just record it and go from there. So consider this class, consider this notes, again, questions asked during Zoom or send me messages, all good there. This will probably be shorter than a normal lesson anyways. I'll probably get on less tangents. And so let's get going. So things that you guys will be doing if it's going to load. Oh, even on a recording, something goes wrong. Anyways, so home, right? For you guys, new week at a glance. Right, singing the blues. I'm upset about my Steelers not doing well last night, but that's all right. I will get over it. But here's the schedule for the week. Working on 5.2. Notes, homework, discussion, quiz, end of the week. That's kind of our week. So nothing too crazy. Homework's a little bit longer. Only one homework this week, but it is a little bit longer. And so let's get to that. And so if you go to modules, go to our unit 5. Right, unit 5.2 lectures where this recording is going to go. I'll give you a little YouTube link for it, and then the actual notes are going to be right there. From there, you're taking your own notes. You're submitting those today. If you have not finished something, please finish it. And 5.2 discussion is really quick. Actually, that's something to talk about right now. Why is it called expected value? Right, you're talking about conceptually, why does it make sense that it's called expected value when we talk about the average of our probability distribution? You do not need to respond to anyone else, right? So this is just your post. It's only worth 4 points, right? So it's worth less than normal, right? So you don't need to respond to anyone else. I just want to know from you, have you thought about why is it called expected value? For homework, there is a PDF attached. All right, so clicking on that link should download you a PDF. And it's a little bit longer, right? Don't worry about turning it in until later in the week. Right, but you need to go through it. And at the very end, it gets into expectation and the games, talking about fair games at the end of class today. And you need to be able to do the average or the mean, the variance and standard deviation for all these different situations. So that's your homework. A little bit longer. I do understand that. It's not due really until the end of the week. If I'm you, I'm probably doing it before your quiz. It should help you do your quiz, right? And so that should be the goal for you as you're going. And so that's kind of the week. Let's get into the teaching. So notes 5.2 is January 11th, 2021. Right, talking about mean, variance, and standard deviation for discrete probability distributions. All right, feel free to pause the video if you need time to write down notes. I'm going to go a little bit faster, probably than normal. I would usually pause more. You can pause me. That's the nice thing. You can pause. You can even mute me, right? Whatever you want to do, right? So, but notes 5.2. And the first thing we're going to do, we're talking about the outcome of rolling a die. We've already done this. We've already talked about this as an example from last week. When I roll a die, things that can happen is I can roll a 1 a 2, a 3, a 4, a 5, or a 6. And they all have a 1/6 chance of happening.
Morning.
So as I'm doing the probability distribution, you're good. It's I think I'm on the headphone, so I don't think they can hear you. So maybe they're going to hear your conversation and laugh. I don't know. So anyways, there's some people here. People I'm hanging out with.
Hi. Hope you guys are getting all this stats stuff. It's really important in life. It's really important in life. So make sure you pay attention because I wouldn't be able to live the life I live without stats.
And it's going to help you make lots of money when you get older. Cheers.
So anyways, yeah, so probability distribution, made of the table. You guys done that. I really quick want to go over the graph. Having a graphical representation, I think, is important as well. And so hopefully you understand we should have a uniform distribution. It should make sense. They're all the same. And so as I'm making probability distribution graphically, probability of X on the Y, and then our X, the different outcomes on the X-axis, right? Their bar graphs, or their bars, are all the same, which makes it uniform. Okay, that stuff we've kind of already covered. So in the same situation, let's move over. Let's put me up there. Let's move over to average or expected value. Those are the same. I should expect some type of numerical value or some type of outcome to happen, right? And so the average represents this. The average, on average, this should happen. On average, I should have the expected value to come out, right? They are the same thing, right? Average we represent with mu. Expected value is E of X. And our formula is the sum of X times the P of X. So for each one over here, I'm going to take the X value and multiply it to its likelihood or probability. So in this situation, I have an X of 1, like that, and then I'm going to multiply it to my probability. This is the same thing as weighted mean. So as I'm coming down here and I'm setting up my formula, I can roll 1 and I can roll it 1/6 of the time. Now I need to sum that, right? So I'm now going to get into the addition part of it. And then 2 times 1/6 plus 3 times 1/6, et cetera, et cetera. So multiplying these out, obviously you just put this in calculator, see what you get. I'll multiply it through. All right. So now in this situation, have all these fractions, add them up, and we're going to get 21. It's not liking me. My pen's not liking me right now. Erase. 21 over 6.
supposed to be here at 10.
which is equal to 3.5. Hopefully that makes sense. As we look at our table, and we have a uniform distribution for our graph, it makes sense that our average is here. Because of this uniform distribution, it's in the middle. It should make sense it's in the middle. Now, part of the abstract part of it is I have expected value of 3.5. My question is, where is that? When can I actually roll a 3.5? Answer is you can't. 3.5 is not a single possible outcome. And that's okay. The idea is over time and over 10 rolls or 100 rolls, you should expect to get 3.5 on average. And so if I added up 10 rolls, I would get 35. I add up 100 rolls, I get 350, right? On average, sometimes I get 1, sometimes I get 6, 5, and etc. Right? But on average, I'm going to get that 3.5 number. The average is really important here. I'm going to use that for variance. The variance to this situation, which is sigma squared, is equal to x, so a value minus the average squared times your probability. The situation, our average is 3.5. And as I start going up, I start with 1. 1's our first number, minus 3.5 squared times the likelihood. They're all 1/6. I'm going to keep doing this. Choose my next number. Remembering when we did variance before, squaring it makes it a positive number. I have 3 minus 3.5 squared times my probability, which is 1/6. Go down to the next line. This is all one equation. We're just going to try to have it so wide. 4 minus 3.5 squared times 1/6 plus 5 minus 3.5 squared times 1/6. And then 6 minus 3.5. Oof. Let's see if my pen's working. Don't like me right now. Times 1/6. Again, going too fast, pause it. Okay. This is just something good. Plug in calculator. You can plug in calculator and you're going to get my variance is equal to 2.9. My pen's going to work. 9167. I rounded it there. On that 7, it was 6 repeating, rounded there. If I want my standard deviation, which is I do want, I'm going to take my variance and I'm going to square root it. So our standard deviation is 1.7078. Again, I'm going a little fast, pause it. There you go, moving on. All right, so we just did expected value. We just did variance and standard deviation. Let's get into fairness and what makes a fair game. If we were going to flip a coin, and as I flip this coin, if there is a heads, my pen is not working. Heads. You're going to win $1. No heads. You lose $1. In this scenario, the question is this a fair game? I think, at least hopefully, you guys instinctively would say, yes, it's a fair game. Right. Heads, win $1. No heads, lose $1. So in this scenario, we're going to prove that. So X equals number of heads. Make a quick probability distribution. So when I flip a coin, is there either going to be 0 or 1? That's going to happen 50% of the time. Okay, great. 50% of the time. So now we're going to do the expected value of this situation. I'm going to lose $1. So that's 0 heads, 50% of the time. And I'm going to win $1. 50% of the time. Multiply that out. It's negative 50 cents plus a positive 50 cents is going to give us an expected value of 0. This is what makes it a fair game. At the end of each roll, each situation, I might win or lose. I might win $1, I might lose $1. I might go 5 in a row where I lose. But overall, over the long term, I'm going to have an expected value of 0. So no one has the advantage here. This makes it a fair game. For it to be an unfair game, where one person has an advantage and one person does not, that would be a number that is not 0, a non-zero number. Someone has an advantage. You might say, well, a fair game is me winning. That's not necessarily the definition of what a fair game is. Fair game is everyone has equal chance to sum up to 0, right? I have a 0 expected value. Not necessarily the same likelihood of events happening, but I'm going to sum up to 0 with my expected value and my average. Okay. that's the lesson. These are the notes. If I went too fast, you can obviously go back into the recording. But this is the general idea of a fair game, the expected value of a discrete probability distribution, variance, and standard deviation. Guys, please make sure you're taking your notes. Make sure you take care of the homework and those types of things. Ask me questions as they go. And I will talk to you later.